Good morning, everyone. Respected resource person, distinguished faculty members, and dear participants. I extend a warm welcome to all of you for Faculty Development Program on Next Generation Computing, Generative AI, Quantum Computing, Agentic AI, and Emerging Technologies. Our today's session is on quantum computing, which is one of the most exciting and transformative technologies which shaping the future of computing. Today's session provides us with an excellent opportunity to explore a field which has a potential of problem solving across the domains such as the cryptography, healthcare, finance, and AI, as well as logistics and scientific research. It is my privilege to introduce today's speaker, Professor Dattatray Raghunath Kale, an eminent resource person with us, whose expertise and experience in this domain will undoubtedly provide valuable insights into this area of technology. Professor Kale is currently serving as an assistant professor in Department of Computer Science and Engineering at MIT ADT University, Pune, and having over 15 years of rich teaching experience across reputed engineering institutions. He is currently pursuing his PhD in computer science and engineering from Pimpri-Chinchwad University. He completed his master's in computer engineering from Savitribai Phule, Pune University, and his bachelor in computer science and engineering from Shivaji University. His academic and research interests include artificial intelligence, machine learning, quantum computing, blockchain technology, data mining, theory of computation, and full stack development. Professor Kale has made significant research contributions with 14 Scopus indexed publications and one Web of Science indexed publication in reputed international journals and IEEE conferences. He also has one Indian utility patent and two Indian design patents with his credit. His achievements include Rajarshi Shahu Maharaj Gunavatta Puraskar from Government of Maharashtra and Best Research Paper Awards at IEEE ICBDS 2025 at MIT ADT University. He has successfully completed prestigious certifications including Microsoft Azure AI 900, IBM Exploratory Data Analysis for Machine Learning and NPTEL courses, and has actively participated in several AICTE, ATAL, and IST faculty development programs. With his vast academic experience, research excellence, and passion for emerging technologies, we are confident that today's session will be highly informative and inspiring. On behalf of all the participants, I, Mrs. Aditya Abhijit Sarokhe, Assistant Professor, Department of Computer Science and Technology, D.Y. Patil College of Engineering and Technology, I extend a warm welcome Professor Dattatray Kale sir. We are delighted to have with us. Thank you for accepting our invitation. So, without wasting much of time, I request you, sir, to start today's session.
Okay, thank you so much, ma'am. Am I audible? Yes, everybody?
So, yes, sir, you are audible.
Okay, thank you, ma'am. So now I'm sharing my screen here. Please check screen is visible to you. Hello?
Yes, sir, screen is visible.
Okay, thank you, ma'am. So thank you so much to all the DY Patil organization team as they have given me the opportunity to present this topic. Okay, so we are now discussing the one of the topic which is not exactly included in your syllabus. Okay, if included as a elective for the last year students or some PG students, because this topic is an under research. But this is very important. When if you are back to the last 3 months, they're having the Tech Wari is one of the program organized by the government of Maharashtra, and this Tech Ware programs, one chief secretary of the government of Maharashtra are discuss on this topic, quantum computing. Also, our chief minister of Maharashtra government, Devendra Fadnavis, also discuss these topics as emerging technology. And now everyone talking about the artificial intelligence, then related AI, machine learning, or related branches or related technologies. But after 3 to 5 years, everyone will be talking on the quantum computing. So due to this today, I will present here the quantum computing, which is redefining the future of computations. Yes. So this is very important topic as a computer science and engineering background faculty members. Okay. So these are the outline for these today's topics, where we'll discuss the introduction of the quantum computing, then we'll discuss the classical versus quantum computing, then core concepts like the qubits, superposition, entanglement, then gates. Gates are important, as we know that in classical computer how gates are works. Same thing is here, how quantum gates and how quantum, after the applying the various quantum gates, how we'll generate the circuits. Then they're having the particular algorithms. Various scientists written these algorithms. We will discuss these quantum algorithms, then applications of this quantum computing, and what are exactly challenges for this quantum field and future outlook. Okay. Now introduction to quantum computing. So what is exactly quantum computing? Because everyone have listened this word nowadays. Okay. So it is not included in your syllabus, but everyone have known this word quantum computing. Okay. So what is exactly quantum computing? So quantum computing is a new type of the computing. Okay. This is the new type of the computing that uses the rule of the quantum physics. Okay. Already they're having the establish a rule of the quantum physics. Okay. If there anyone having from the MSc physics, or they have completed their PhD in physics, they well known about the quantum physics or quantum physics rules. Okay. Now these quantum physics rules are used to process the information. Okay. These quantum these quantum physics rules, okay, whatever the quantum physics rules, these rules are used to process the information. Okay, this is the thing about the quantum computing. Now we are in our classical computers, we are not using the quantum computing rules or quantum physics rules. We are directly using here the our straightforward the machine languages. But here these computing, this type of the computing uses the quantum physics rules for processing these informations. So it's very different from the our traditional computers that we use today. Okay. So this is the brief information of the quantum computing. So in classical computers, okay, classical computers means whatever we are using today, these are all the classical computers. Okay, all the applications we are running on the classical computers. So classical computers, they are built on by using the bits 0 and 1. Everyone know that whatever we are doing with the computer, these are converted into the machine language 0 and 1. So our classical computers are using 0 and 1 for computing purposes or to do calculations. While quantum computers, now this is a very important. Quantum computers uses the qubits. Okay, they are using this qubits. This is the very fundamental points in the quantum computer. Instead of these classical 0 and 1 bit, quantum computers uses the qubits. Okay. So These are the computers which are built by using the qubits. So qubit is the fundamental component of the quantum computers. So just again, I revise here. Quantum computing, it is the new type of the computing. Okay. And this new type of the computing uses the quantum physics rules for processing our information. So as when we are using the classical computers, the process our information, processing the information, they are using or they are built on using the machine language or machine bytes. That's mean 0 and 1 byte. But when we are using the quantum computers, these quantum computers are uses the qubits. Okay. Now, so what are the qubits? Just these questions are arises in our mind. Okay. As quantum computers are built by using the qubits, then what are the qubits? Okay. Qubits are also just like the our 0 and 1 bit. Okay. Qubits are just like our 0 and 1 because our 0 and 1 bits are used in our traditional or in our classical computers, and qubits are used in our quantum computers. But what are qubits? Qubits are also same, but what is the exact difference here? These qubits, which is also called as a quantum bit, okay, which is also called as a quantum bit. This is the basic unit of the information. Very important. This is the basic unit of the information in quantum computers. Just like the bit is the basic unit of the quantum classical computers. Okay. When we are writing the any program, when we are doing the any activity with the classical computers, all these are converted into the 0 and 1 bit into the machine. Same thing is here. Okay. So these quantum bit or qubit is a one quantum bit. It is the basic unit of the information in quantum computer. Okay. Just like the bits in the basic unit in the classical computers. See here. So they're having the difference. What is the exact difference? A bit can be only 0 and 1. Okay. Bit can be only 0 or 1. Okay. Either 0 or 1 when we are writing anything. So when we are writing the, for example, A having their bit formats different, B having their bit formats different. So bit can be only 0 and 1, but qubit, a qubit can be 0, can be 1, or both at the same time. Okay, this is called as a superposition. Superposition is one of the fundamental rules of the quantum computers. We'll discuss this superposition in detail in next slides. Okay, so this qubit, it's maybe 0, it's sometimes maybe 1, and it's sometimes it is both at the same time. Okay. Now it is just like think if you are spinning the coil. Okay. If you are spinning the coil in the air, so what happens when it's still it shows head and tails. Okay. That means before the spinning it shows the head and tail. Okay. But when it's spinning in the air, it mixes the both until it lands on the ground. Okay. When this is very important example to understand the quantum computers or quantum computing. So if when we are spinning the coin, it's when it's available or when it's in the our ground or before the stand spinning this coin, it shows the heads. Okay, for example, heads shows 0 and tail shows 1. But when we are spinning positions in the air, what happens? It shows the mix of both. Okay, when we are seeing that, it shows the mix of both. We can't say that this is the head position or this is the tail position. Okay, so it shows the mixing of both. It lands. This situation creates the quantum bits. Okay, this situation creates the qubits. So qubit is like this spinning this coin. It can be mixed state of 0 and 1. Okay, it is not just like the 1, or it is just not just like the 0, but it shows that it is the mixed state of the 0 and 1 at the same time. This lets quantum computer process many possibilities at once. Okay, so it can shows that they're having the many possibilities. It can works on the multiple possibilities. So due to this, we are saying that the quantum computers are highly computing, or it can solve the complex problems which are not solved or not handled by their classical computers. Okay. So we are showing here the one blue sphere. This is the 3D diagrams. Okay. Where the in the left side, if you are seeing in the left side is showing that they're having the 0 bit and 1 bit. Okay, so classical computers are based on the 0 bit and 1 bit. But if you are seeing on the right side, here I'm showing the one blue sphere. This blue sphere is what? This blue sphere is the just like the example of the coin. When we are showing the spinning of the coin, at that time what happens? So it cannot be directly one zero, or it cannot be directly shows the one. Okay, it shows sometimes mixture of the 0 and 1, and it is represented by these. These are called as a kept 0 and kept 1. Okay, these are the positions, or these are the states. Just like the 0 and 1 in quantum computers, this is called as a kept 0 and kept 1. Okay, so these are the two states here, but they're having the another one state. When we are signing this coin, at that time it can be mixture of both, and it is showing by this kept 0 plus kept 1 divided by square root of 2. Okay, and it is shown by these red lines. Okay, it is shown by these red lines. It may be sometimes you kept 0, it may be sometimes kept 1, or it just showing that the mixture of both. Okay, this mixture of both is shown by this formula. This formula is very important. This is the one of the mathematical computation here. Kept 0 or plus kept 1 divided by square root of 2. Okay, so this can be shown by using this blue sphere. These are the qubits. Qubits are shown by this 3D blue sphere. Now, so in our mind, how these qubits are made? This arises question in our mind when we are showing that these are the qubits. Okay, this is the theoretical information about the qubits, but how these qubits are generated, how these qubits are made, this another one important question arises in our mind. So how these qubits are generated? So to build or to make these qubits, scientists use a very tiny things. Okay, so these tiny things are which thin things? These tiny things are coming from the physics. Okay, just like the atoms, electrons, or light particles. Okay, when any scientist wants to generate the qubits, they are uses the very tiny things. These thin things are coming from the physics, which are the atoms, electrons, or light particles, and control them very carefully. So these tiny things follows the special rules of the physics. Okay. So by using these tiny things, we can make the qubits as a by using the atoms, electrons, and light particles. Okay. Now, so which are the quantum rules used to create these qubits? These are the very two important quantum rules. Okay, quantum physics rules. When anyone want to build, any scientist wants to build these qubits, they want to understand, they want to know the two fundamental rules of the quantum physics. Okay, so which are these rules? First is the superposition. This is very important rule. First is the superposition, and second is the entanglement. Okay, so these both rules are important. On these both rules, our quantum computers are created. Okay, our quantum computing is based on these fundamental quantum physics rules. Okay, these rules are already defined in the quantum physics, superposition and entanglement. Okay, so by using these two rules, we are creating here the quantum computing or quantum computers. Yes. See here. First, we will discuss the superposition. So what is superposition? Just in previous slide, I have shown you superposition concept. So what is superposition? See here. Superposition means a qubit can be in both 0 and 1 at the same time. Okay. When we are spinning the coin in the air, We are not saying that they're having the only zero state or they're having the only one state. They are having the mixing of zero and one state. Okay, this position is called as a superposition. Yes. So superpositions means the qubit can be in both 0 and 1 at the same time. So in classical bit can exist in two possible states, either 0 or 1. Okay, that means when we are switching the switch on the our light or switch off the our light, they're having the two possibilities now. When we are pressing the 0 at that time, light will be off. When we are pressing the 1 at that time, light will be on. So only two states are possible in our classical computers, or only two states exist in our classical computers, and we are labeled them just like the 0 and 1. But in our superposition rule, in our quantum computers, superposition rules, they're having the, it can be both 0 and 1 at the same time. So we are discussing here the mathematical, how we are representing these mathematical superpositions. So superposition is the linear combination of 0 and 1, and it is written by kept 0 plus kept 1, and these are assigned with the beta and alpha. Okay, alpha and beta. So why we are assigning this alpha and beta? Alpha and beta, these are the probability amplitudes. Okay, alpha and beta, these are showing the probability amplitudes. So when we are showing these kept psi, okay, this is called as a kept psi. So kept psi is the state of the qubits. Kept psi is the state of the qubits here. Kept psi written in this type. So every this is the mathematical representation of the quantum computing concepts. Superposition, then our states, kept one, kept zero. So kept psi is the state of the qubits. Okay, when we are flipping the coin, it can be generates the states. So state of the qubits is represented by this kept psi, and kept 0 and kept 1 are the basic states. Okay, kept 0 and kept 1 are the basic states. These are the read as a kept 0 and kept 1. And alpha and beta are the complex numbers which are called probability amplitudes. Probability amplitudes means what? It sometimes may be your situation is just like the when if you are considering the two states are ending points 0 and 1, but your position, your qubit's position is showing the between the 0 and 1. Okay, so possibility or probability amplitude showing that sometimes your position is moving towards the, for example, 0 is kept into the left directions and 1 is onto the right directions. At that time it may be on the left side, sometimes it may be on the right side. So these are showing by the your complex numbers, these are showing by your probability amplitudes. Okay, so this is the kept psi. Kept psi is very important. Kept psi is used for representing the superposition in the linear combination of the 0 and 1. Okay, this is the concept of the superposition. Yes. So see here. Now here the, again this is one of the bliss sphere. So here one of the pole represented by this kept 1 and another position, another pole is represented by this kept 0. But when we are calculating this superposition, for example, superposition, when we are calculating the superposition with our qubits, this qubits is sometimes moving towards the, or it's towards the kept 0, or maybe it keeps to the kept 1. Okay, sometimes its position is towards the 0, sometimes its position is the towards the kept 1. So it's showing by these kept psi. Okay, this kept psi, and this kept psi is the combination of both 0 and 1. It is not equal to 1 when it will going to be 1, when it will be given 1, when it directly placing to this 0 position, or when it will be going into the 1 position. When it will be going into the 0 position, you are just like the, it's in the normal positions. Okay, it's showing the either 1 or 0. But when it is the in the middle, or not, we are saying that the directly middle, because this is the middle point is here, it's just towards the 0 side or it just towards the 1 side. Okay, so it is the combination of the 0 and 1. And whenever we are showing that this is not only towards the our 0 or towards the our 1, it's showing the probability amplitudes. Okay, it's showing the probability amplitudes, and this shows by using this alpha and beta. Okay, so a qubit stays in superpositions only when it is not observed. This is very important. We are saying that qubit stays in superposition when only when it is not observed. When we measure or observe it, now I want to measure their states. At that time, superpositions ends. Okay, at that time, superpositions ends, and qubit becomes either 0 or 1. Okay, that means this position of your qubit will be going into the either 0 or either 1 at the time of measurements. Okay, so this is called as a collapse of the wave function. Just when we are spinning the coin is now in the inner ground. Okay, that means either it will be available head position or either it will be available onto the tail positions. But when in the air, when we are spinning the coil and it is available into the air, at that time we cannot measure them. Okay, either in which state it is available. Okay, so when the coin is available into the our ground, at that time it collapse the wave functions. Okay, that means your superposition states are collapsed and we are measure them into the either 0 or 1 state. Okay, now so just imagine line here. Okay, here 0 and 1. In the left side they are having the 0, in the on the right side they are having the 1. Okay, so this left side is represented by this capped 0 and right side is represented by this capped 1. But qubit can be anywhere between the 0 and 1, not just at the end. Okay, it may be sometimes at the end, but not just at the ends. So qubits may be between the 0 and 1. So if it is near to 0, for example, here your qubit is here, it is near to 0, that means more chances of occurring the 0th position. If it is 1, more chances of the 1. Okay, if it is into the this side, your qubit is into the this side, then more occurring the, or it will be happens 1. Okay, if it is in the middle, for example this 0 and this 1 having, this is the middle. Okay, this is the middle positions, this is the middle positions. If your qubit is just in the middle, then both 0 and 1 are in equal. Okay, so in this way, we are representing our qubits in superpositions. So this is in between state in the superposition. Okay. Now, after that, we'll moving towards the new, another one new rule. This new rule is the what? This is another one new rule. New rule is the quantum entanglement. Okay. So our qubits and our quantum computers are based on these two rules. First is the superposition rules, and second is now quantum entanglement. What is meant by quantum entanglement? So quantum entanglement is when two qubits are strongly connected to each other. Okay. Quantum entanglement is when two qubits are strongly connected to each other. How we are saying that these situations, just quantum entanglement means two things are magically connected. Two things are magically connected. If you change the one, the others change instantly. And condition is what? Even if they are far away. Okay, just like the Judua Bhai. Okay, in Judua film, you have seen in the Judua film what happens when here one character is doing whatever activities, same are reflected into the next characters. Okay, so quantum entanglements means two things are magically connected. Okay, that means if you changing the one, others change instantly. Okay, and it's not required these two things are close to each other in the one sector. it is even in the far away positions. So in one line definition of this quantum entanglement, this entanglement means two qubits are connected in such a way that the state of one immediately affects the other state. Okay. This entanglement means two qubits are connected in such a way that the state of one immediately affects the other state. Okay. How? See here. Here I am showing the one two girls are there. Okay, here. So how this quantum entanglement works? First twin laughs. Okay, two girls means twins are here. First girls just laugh. First twin just laugh. Instantly second twin feels sad. Okay. So instant connections are there between this. This is nothing but your quantum entanglement. So we have defined here entanglement means two qubits are connected in such a way that the state of one immediately affects the other. When we are changing the state of the one qubit, first qubit, for example, first qubit having a state 0 and second qubit having the state whatever 0 or 1, when we are changing the state of the first qubit, it is instantly or immediately affecting the state of the next qubits. Okay, these are closely connected to each others, but it is not conditions that they are closing to the each other in one place. If they are away from these two, then it affects. Okay, this is nothing but the entanglement, and these are showing by these twins. Okay, now quantum gates. So after seeing these two rules, quantum physics rules, superposition and entanglement, we are moving towards the another one concept, quantum gates. Okay. So already we know that the in classical computers are also having the gates and or not and NAND and okay, all these gates, and by using these gates we are performing the task. Okay. Now same thing is here. When we are generating the languages, when we are developing the languages, we require these gates, and we need to generate the circuits by using these gates. And then we are developing our programming languages for these quantum computers. So quantum gates, what are the quantum gates? Just here. Quantum gates are the operations that change the state of the qubits. Just like in your classical computers. In classical computers, what happens? We are using the logical gates. Okay. Just like the classical computers, we use the logical gates and or not. Okay. When we are applying these gates, logical gates to the your current bit, when we are applying it, it will be changes their states. Okay. Same thing is here. Quantum gates are the operations that change the state of the qubits. Okay, state of the bits are changing in the classical computers, and state of the qubits are changed in the quantum gates or quantum computer states. Okay, just here qubits are available. Okay, so these quantum gates are the operations that change the state of these qubits. Hmm? Just you imagine that. Okay, and already we have studied the computer organization and architectures course in the, I think in the second year of the our engineering syllabus. So all we have used these gates. Okay, applying these gates and changing the state of the our bits. Okay, same thing is here. These are the quantum computers which uses or which are built on these quantum gates. Okay. So they are having the different types of the quantum gates. Very important. These are the very important part when we are studying these quantum computers now. These are the very important part. Different types or different categories of these quantum gates. First is the Pauli gate. Then second is the Hadamard gate. Third is the Faso gate, shift gate, phase shift gate, and fourth is the control gates. Okay. So when you want to start to study in detail related to the quantum computing or quantum computers, you need to study these four gates. Okay, Pauli gates, Hadamard gates, phase shift gates, and control gates. Okay, now we are moving towards these gates in detail. So first is the Pauli gates. Okay. So Pauli gates are represented by in this X, Y, Z. These are the basic gates that change the qubits in simple way. Okay. Pauli gates, these are represented by this X, Y, Z, and these are the basic gates that change the qubits. Okay, state of the qubits in simple ways. So just see here, when Pauli X gate, okay, just like the your NOT gate. When, for example, we are showing here the one matrix of the 2 by 2 matrix 0, 1, 1, 0. So clips the qubits, then kept 0 will become a kept 1. Okay, state will be changed and kept 1 will become the kept 0. Okay, same it is just like the your classical computers NOT gate. Okay, Pauli gate, these are the basic gates that change the qubits in simple ways. So it is represented by this Pauli X gate, just like it is just like the parallel to their NOT gate in available into their classical computers. When we are applying the NOT gate, you know that we are writing the NOT gate in this way. Okay, in this way, just like the P, not P. Okay, same thing is here. When we are applying the Pauli X gate, X is just when we are considering here one of the matrix 0 by 2 by 2 matrix 0 1 1 0. So when we are applying these qubits or flipping these qubits, these kept 0 will become kept 1 and kept 1 will become a kept 0. Just like when we are in classical computers, 0 will become applying the NOT gate, 0 become the 1 and 1 become the 0. Okay, so this is the fundamental Pauli gate is the fundamental gates of the class quantum computers. Now next is the Pauli Y gate. Okay, so Pauli Y gate is represented in this way. It changed the state with phase shift. Okay, it changed the state with the phase shift. So here also 2 by 2 matrix 0 I minus I 0. Okay, so it is harder to visualize. That means we cannot visualize. Yes, it may be visualized, but it is important in the quantums operations, Pauli Y gate. And Pauli Z gate, when it does not change the 0 or 1 directly, but it only changes the phase. Phase or some slightly changes is applying, slightly changes will be doing when we are applying this Pauli Z gate. Okay. So here it directly not changing the 0 or 1. Okay. It directly cannot change the 0 1 or 1 0, but it may be slightly changing. Okay. So slightly changing their positions or slightly changing their phase. This is when we are applying the Pauli Z gate. Okay. Now after this second gate is the Hadamard gate. Okay. So Hadamard gate. What is Hadamard gate? Or it is represented by this H gate. Okay. Hadamard gate. So this Hadamard gate is used to put a qubit into the position, superpositions. This is very important. When we want to convert or when we want to create the superposition state, when we want to create the superposition state, at that time we are applying the H gate, and H gate is nothing but the Hadamard gate. Yes. So how this Hadamard gate works in qubit? If qubit is in the state 0, after the applying this Hadamard gate, it becomes both 0 and 1. Okay. Why? Why both 0 and 1? Yes. Is there anyone? Anyone answering this? Why the 0 and 1? Both 0 and 1? Because this Hadamard gate is used to put a qubit into the superposition. And what is the rule of superposition? What is the rule of superposition? Yes, what is the rule of superposition? In superposition, it's available always into the both combination of the 0 and 1. So that's why when we are applying this Hadamard gate H to the our 0 position, it becomes the 0 and 1. And when we are applying this Hadamard gate H to the 1, it also becomes the 0 and 1. Okay. Whatever, when you are applying this Hadamard gate H gate to the 0, it will become a 0 and 1. When you are applying this head gate same to the 1, it will become a both 0 and 1. Okay. Now, for example, here I am showing one example. So suppose initially they're having the 0th position or 0th bit, 0th qubits positions. Now, after applying this headmart gate, okay, after applying this headmart gate, H gate, output is the 0 and 1 at the same time. Output is the 0 and 1 at the same time. It shows that they're having the superpositions. Okay, output is into the 0 and 1 at the same time. That means it shows the output is into the superposition states. Okay, so qubit is now in the superposition. Yes, qubit is in now in the superposition. Yes, yes, na correct na. You apply on initial qubit. Okay, initial qubit. Suppose the initial qubit is the 0, it will be create the 0 and 1. And it suppose initial qubit is in the 1, it will create the 0 and 1. Why 0 and 1? Because it's available into the superposition. Just one example I have given here, light of 0. Okay, when you are pressing the button, light is the off now. So off is represented as 0. After the applying this head gate, H gate, light is dim. Dim means what? Dim means what? They're having the light now, but it's not as usual. Okay, when we are pressing the button and when our light is on at that time, our bulb is on now. But they're having this some situation. Okay, and everyone has know this situation because they have know that they're having the dim light. We are just saying that these are the dim light. Dim light means it is the middle part, or it is the middle way of, it is not in the off position, off state, or it is not in the on state clearly. So this middle state in between on and off is nothing but their superposition. Yes, yes, everyone get this. Light is off 0 after applying the head gate. Light is dim. That means in between the on and off state, and this state is nothing but their superposition state. Yes. Now, so these gates not change the 0 or 1 directly. Same, these gates, this headmart gate is not changing the 0 and 1 directly. They only change the phase. That means internal behavior of this. So just imagine like a song, but tuning bit is different. Okay, we are saying that the song is old. For example, old song. They are having the multiple old songs are available, but when we are making them modern, okay, when they are making them modern, all the songs, all the text of these songs, whatever you are listening, the songs same, but it is playing into the different way. Okay, modern levels are available between them. So this is nothing but the internal behavior, changing the internal behavior. Next gate is the control gates. These gates work on the 2 qubits. Okay, control gates are works on the 2 bits. In your name, it's also showing that the controlling the 2 bits. So these works on the 2 qubits. What happens when one qubit control the other qubit or target? Just imagine. I was showing you one previous image or previous diagram into the entanglement positions. If we are seeing the twins, when one twin is in the happy mood or one, just like it is laughing, automatically next or another close twin will be in the sad positions. That means when we are controlling the one, it others on the next qubit. Okay, this is called as the target qubits. Okay, when one qubit is in the control, then other qubit is in the target positions. Okay, so these gates works on these 2 qubits control gates. Rule: if control 1 change the target, if control is equal to 0, do nothing. Just same rule. So like if switch A is on, then change switch B. Hmm? These are control gates. This is the first phase shift gates. Now, how quantum computer works? Just see. whatever the concepts related to quantum computing, superposition, entanglement, then quantum gates. After discussing these concepts, we are moving towards the how quantum computers works. How quantum computers works. So quantum computers works using some important components. Which are these important components? First is the qubits. Okay, just qubits. This is the physical implementation. Qubits are made using the real system like the supercomputers, then ions. That means these are the charged items, ions. Then they are having required the cooling systems. Okay. So quantum computers need extremely low temperature, close to absolutely minus 273 degrees centigrade. This is very, very important. When anyone asking you, where is your quantum computers? You can show your quantum computers. No, this is called as a hardware restrictions for these quantum computers because quantum computers needs extremely low temperatures. Okay, extremely low temperatures. That means close to absolute to the zero. Now minus 273 degrees centigrade. When we are changing this temperature or changing this, then they are having the noisy gates will be generated. Okay, noise states. And now today's the noisy states are available. Okay, NISQ test state is available for the quantum computers. Okay, in India, it's mostly NISQ tests are available. Okay, so quantum computers need extremely low temperature. Why? To reduce the noise. Okay, now there are the noisy states, but to reduce the noise and keep quantum bits or qubits stable, we require this cooling system. Okay, so quantum computers needs the very low temperature near to zero. Okay, now that's why these qubits are stable. Okay, that's why these qubits are stable. Now error correction and challenges. So qubits are very sensitive. Yes, qubits are very sensitive because it's made by these atoms and superposition computers. So qubits are very sensitive. Small disturbances can cause the errors. Okay, qubits are very sensitive. So small disturbances can cause the errors. So special error corrections methods are needed here. But this is difficult and very complex. Okay. If you want to implement the quantum computers, it requires the cooling system, and cooling system is nearly about the up to the zero, absolute zero. And nowadays it's required the minus 273 degrees centigrades because we require to reduce the noise and keep the qubits in the stable positions. Now, when they're having the errors are occurs within these qubits. Why? Because due to this, just like the noise or any other disturbances, we require the error correction methods. Yes, we require the error correction methods, but these error correction methods are also difficult and complex in nature. So this is their how quantum computers work. Okay. Now, quantum computer hardware platform. So hardware platforms are the physical systems used to build these qubits. Hardware platforms are the physical systems. Okay, just like they were classical computers. Classical computers are also hardware platforms, and it is also physical systems. Yes, same thing is here. Quantum computers are the physical systems to build these qubits. So main types of the hardware platforms. First is the superconducting qubits. Okay, first is the superconducting qubits. It uses the electrical circuit at very low temperature. It uses the electrical circuit at very low temperature and work near to the absolute zero, just like qubits. Qubits are required the minus 200 degrees centigrade temperatures. So two hardware platforms. First is the superconducting qubits use electrical circuits at very low temperatures. And second is the photonic qubits. It uses the light particles, and light particles, you know that these are the photons. It is the part of the physics. Okay, so photonic qubits uses the light particles. Quantum dots, another one hardware platform. Quantum dots, this uses the tiny semiconductor particles. Okay, So different hardware platforms use different physical methods to create and control these qubits. So anyone, if you are anyone asking you the quantum hardware or quantum computers hardware platforms, then you can say that these are the main three types of these quantum hardware platforms: superconducting qubits. These superconducting qubits uses the electrical circuit at very low temperature. Then photonic qubits uses the light particles or photons, and quantum dots uses the tiny semiconductor particles. Okay, so these are the different hardware platforms, but these are used to make the physical method. These are the physical methods to create and control the qubits. And when we are saying that the creating and controlling qubits, that means we are creating the quantum computers, okay, and handling the quantum computing. Yes. Now, quantum computer hardware platforms are physical technologies. Okay, this is very important. Quantum computer hardware platforms are the physical technologies like the superconductor, then ions, then photons used to build and operate these qubits. Okay, so quantum computer is hardware platforms are physical technologies like the superconductors, ions, and photons used to build and operate these qubits. Okay. Now, quantum software platforms, this is very important. As a computer engineer, we need to know that these software platforms, okay, hardware platforms also we need to know. But when we are working with the hardware platforms, they are having some electronics engineers, they are having some physics background engineer, not we are saying that engineers, but scientist. And now your role is as a quantum software engineer, software platforms. So first is the QuizKit programming language. Very important. QuizKit is developed by the IBM and it uses the Python programming language. Okay, helps to build and run the quantum circuits. This QuizKit, which is developed by this IBM, and it uses the Python programming language and it helps to build and run the quantum circuits. How we are using this QuizKit? First step. First step is install the QuizKit. Okay, just like a PIP, install the QuizKit. Second step is import the libraries. Okay, whatever the libraries are required, because Python is the very rich in library. We import these libraries required for implementing and for running the QuizKit. Then create the quantum circuit. Okay. So next step number 3 is create the quantum circuit. Step number 4 is apply the various gates. Whatever the gates we have studied now, phase shift gate, then Hadamard gate, all these gate, Pauli gate. So all these gate you can apply here. Step number 5 is measures the qubits. Okay, when we are showing that our waveforms are stopped at that time, we can measure our qubits. And step number 6, the run the program. Okay, so this is the related to the quantum software platforms. Just you can see this program, qubits programs. So this is the one of the Python code. So from Qiskit, you can import the quantum circuit AR and execute. Okay, this AR is one of the simulator. So quantum circuit is generated by using this QC is equal to quantum circuit 1 comma 1. Okay. See here, we are first importing these our libraries required for the QuizKit. So from QuizKit, import this quantum circuit AR to execute. Now you generate this quantum circuit by using this QC is equal to quantum circuit. When you are importing this library, na, then automatically you are executing this code. If you are not importing this, na, you cannot run this code. Okay, this is simulators. So 1 comma. Then when we are applying the Hadamard gate, this is showing the Hadamard gate, and QC measures it will be showing into the 0 comma 0. So simulators here, simulators are showing that the simulator is which simulator are using AER. Okay, AER dot get backend quantum simulators. So result are we are executing this quantum circuit, then simulator, and then shots. How many times it will be run? So dot result. then counts will be showing that results dot get counts. Okay, and print this counts. Output will be 0. When we are running into the 100 times, how its positions will be changed. 0 will occurring into the 500 times and 1 will be occurring into the 500 times. That means this shows that both 1 and 0 are appearing the same times. It is just like the superposition is working. Okay, just your quantum computer superposition is working. So these programs are important when you are starting to learn the quantum computers, learn this quantum computing for your final year students or any PG students. At that time, they know that how the we are showing the prototype here, because quantum hardware is the restrictions or limitations for us. But there are having some large tech companies which are directly working on it. They will providing this type of the prototypes for you. You can implement it this. Okay, so you can install this quiz kit in Google Colab and run quantum program easily using the simulators. Okay, so they're having the any platforms, just like you are implementing your machine learning projects into the, you are using the various Jupyter notebook, Anaconda environment. Just you can write this code into this also Jupyter notebook. If your computations are large and you required the GPU instead of the CPU, at that time you move towards the Google Colab also, because Google Colab is the cloud platform. So you can run your code by using this Google Colab. Okay, but you required to install the kit into the Google Colab. Okay, so this is the one of the sample code for this quiz kit. Now, what is the current state of the quantum computers? Yes, what is the current state of the quantum computers? What is current state? Yes, in India or in the world, in India or in the world, what is the exactly state of these quantum computers? See here, these quantum computers are still in the early stage. Okay, in the development phase, not completely developed, under the development phase. So it is in the early stage. So not fully powerful yet. Everyone are in the research mode of this quantum computing. So they're having some errors. Okay, so very expensive and this is complex, and this stage is called as NISQ, noisy intermediate scale quantum. So now the quantum computers, if anyone asking you the current position or current state of the quantum computers, then you can tell them current position or current state of the quantum computers are the NISQ. This is very important. Whatever you are learning now, you start this state NISQ. NISQ state, noisy intermediate scale quantum. Okay, NISQ state, noisy intermediate scale quantums. Okay, so this is the current state. What can they do today? Now see here. Now, what can they do today? They are used for some specific task. This for the research. Okay, everyone know that physics, chemistry, and all other fields. Then optimization the various problems. Then cryptography experiments. We will discuss cryptography case studies, but they are not used for daily tasks. Okay, they are not used. These quantum computers are not used for the daily tasks like they were laptops and mobile phones. Okay, so we are weighing it. It will be become a completely perfect. Na, you can't imagine that how our IT industry or how our whole world will be changed. Yes. Next. So who is using them? First is the big tech companies. Okay, mainly. First means mainly it uses the big tech companies because it is under research. Okay, big tech companies. I just like the IBM, Google, Microsoft. These companies are developing these quantum computers. Okay, these companies are developing these quantum computers. IBM, Google, Microsoft. Now, some startups are there having. Second is the some startups. Okay, but these are not in our countries, but it's from the whole world, just like the iron q, then rigetti computing. Okay, these startups are use these quantum computers, are they are now developing the quantum computers. Some research institutions and universities, okay, scientists and students use them for the research purposes. Okay, in under in if you are seeing the in every university, not only in India but overall all the world, everyone are now doing the research in the quantum computers, okay, or quantum computing, because everyone want this to optimize their problems, to solve their complex things. And when these quantums works, just imagine that whatever the work require, whatever the time required to solve the one problem in the classical computers or by using the classical computers, for example, it requires the 10 seconds or 100 seconds, within the microseconds, okay, within the microseconds, your problem will be solved by these quantum computers. Okay, so it works 500 times better than your classical computers. Just imagine that 500 times better than your classical computers. Okay, so today quantum computers are in the early stage and are mainly used by the companies and researchers, but they are not used by the common people in their daily lives. Okay, now quantum algorithms. Okay, we are moving step by step. How quantum computers works, what are the restrictions of the quantum computers, which are the software tools for this quantum computers, hardware platforms. After that, we are moving towards the quantum algorithms. You know that algorithm is outline, okay, and everybody know that the our whole structure is depending. Our computers are depending on these different algorithms. So they're having the some algorithms which are designed and developed by the scientist, quantum scientist. So Shor's algorithm, you know that these Shor's algorithms are used in your previous classical computers also to encrypt or decrypt, just like the RSA. Okay, RSA is the Revis-Shamila algorithm. Okay, which is used in the information security. So this RSA algorithm is used in the previous classical computers to encrypt and decrypt the this your whatever the informations. Okay, so this Shor's algorithm is also used for the encryption purpose in the quantum computers. So it can factor very large numbers quickly, which normal computers struggle with. Okay, this is why it's important for cyber security. That means it can change, totally change. For example, if you want to crack the password or if you want to crack the any systems, at that time these Shor's algorithms are not sufficiently when they're having the sorry, RS algorithm is not sufficiently when they're having the Shor's algorithm in crypto systems. That's why these quantum computers are important. When quantum computers generates their threads, and these threads are coming into the our classical computers, at that time our whole systems will be break, our data will be crack, our applications will be crack. All these threats are coming into our systems. So cyber security is one of the fundamental field aligned with these quantum computers. Okay, so second algorithm is the Grover's algorithm. It helps to search faster in database. Okay, so Grover's algorithm, which is used to search, it's in the faster in database. So instead of checking one by one, it finds the answers much quickly, useful for things like the searching passwords and large data sets. Okay, this algorithm is used to help search the contents faster in the large database. Okay, so it cannot be checked one by one. Okay, now traditionally one by one, traditional computer checks the one by one bits, but it cannot be checked one by one. Okay, so it works 500 times better than the classical computers. So it works much quicker, and it is useful for things like the searching the passwords on the large data sets. Now, applications of the quantum computers, just like the healthcare. drugs discovery, potential holdings. Then second is the finance, risk analysis, and portfolio optimization. Third is the cyber security, quantum cryptography. That means threat to the current encryption systems. Okay, these are the three important domain fields where these quantum computers are used in next few years. After the next few years, just like the 3 to 5 years, within the 3 to 5 years, all these domains will be changed, because now we are talking about the artificial intelligence. No, now after that it will be era of the quantum computers. So challenges and limitations of this quantum computing. What are the exactly challenges in front of quantum computers? Challenges and limitations of this quantum computer. Imagine it's not um, now currently it's not available for the common people or for the daily use. Yes. So challenges and quantum limitations of quantum. When you are doing your studies, when we are seeing one problem statements and handling this problem statement by using these quantum computer simulations, at that time you will be facing the various challenges, and you can note the challenges at that time. So challenges, noise and decoherence. Okay. So what is mean? Noise and decoherence is one of the challenge in front of these quantum computers. So what is mean by noise and decoherence? See here, quantum bits are extremely sensitive, as we have discussed in our previous slides. Qubits, qubits are maintained under the minus 273 degree Celsius. Yes, qubits are maintained under the minus 273 degree temperatures. And these qubits are extremely sensitive, okay, to their environment. So external disturbances, just there I have the heats. If heat is coming there, it will change their positions. Okay, it will change their state. At that time, when when qubits change their position or state, it affects the your performance, or it affects these outputs. Okay, so it's sensitive to their environment. So external disturbances like the heat, radiations, vibrations, these are introducing, or these are creating the noise. Yes, these are introducing, or these are creating the noise. Then second is the decoherence. So what is my decoherence? Qubits lose their quantum states, just superposition or entanglement over time. This process is called as a decoherence. Okay. When they're having the disturbances that occur, then decoherence is created. In decoherence, qubits lose their quantum states, and we require the quantum state. Na? We require the superposition, we require the entanglement. Then and then we are implementing our task through the by using these quantum computers. Okay, so if you don't want to lose their qubits into their particular states, we require the quantum computers to maintain into the very what we are saying, the very low degree temperatures, just like the minus 273 degrees centigrade temperatures, and it's save we are avoiding the various noises. Okay, whatever the noises, just like the heat, radiations, vibrations, etc. Then and then only we are saying that the whatever the outcomes are coming from this quantum computers are correct. Okay. So superposition and entanglement, these are the two positions, these are the two states which are the fundamental states in the quantum computers. And when due to these noise, due to these disturbances, these states are losing, we are saying that the decoherences are happen, or this process is called as a decoherences. Okay. Second is the error rates. So what is the exact meaning of this error rates? So quantum operations are not perfectly reliable. Just we are saying that here. Why not reliable? Because not quantum computers are exactly available for the common man. So quantum operations are not perfectly reliable and gates applied to the qubits are often produce the errors. Why? Because of this noise and decoherences situations. So this is called as error rates. Okay. Next challenge is what? Error rates. So error rates are increased because quantum operations are not preferably reliable. Why these are not reliable? Because they're having slightly changes. Okay, because they're having the disturbances. And when we are generating these qubits by using the atoms, electrons, photons, at that time it requires to maintain in very sensitive manners, okay, sensitive way. And if very slightly teeny changes are occurs, then automatically it affects on their positions, okay, quantum positions. And quantum positions means your superposition and entanglement. And due to this noise or due to this errors, positions will be changed or positions will be lost. At that time decoherences are happens, and these decoherences or noises are happens. That means error rates are created or error rates are generated. Yes. Then next challenge is scalability issue. What is the scalability? Scalability means, so building a large quantum computers with many qubit is extremely very difficult. Yes, building a large quantum computers with many qubits. If you are finding, if you are searching the how many qubits are generated in India, if you are searching the how many qubits are generated in the China and in the US, then you can see that China near about 250 qubits, US near about 200 qubits, but India only 70 to 40 qubits are generated. Okay, so building a large quantum computers with many qubit is extremely difficult. So current systems have limited qubits, tens to few hundreds. That means I have seen given some examples. Okay, now it will be changes. Okay, but US and China, these are the two countries are mainly focused on these quantum computers. And if they are successful in future and developing these quantum computers, then we will get the very large setbacks. Okay, so our attention should be on these quantum computers. So scalability issues, building large quantum computers with many qubits is extremely difficult. Then current systems have a limited qubits, that means tens or to few hundreds, and many real world problems needs millions of the qubits. This is very important. Okay, if we solve the many real world problems, it requires the what? It requires the millions of the qubits. And scaling up is not just adding more qubits, it increases the complexity exponentially. When we are creating a large or maximum qubits now, at that time, complexity is exponential. Okay, complexity exponential. We need to implement our projects, or we need to we need to require the minimum qubits. Okay, on the basis of the minimum qubits, we can solve your problems. Okay, this is very important. Okay, this is called as a scalability issues. Yes, scalability issues is one of the fundamental challenge in every new technology. When you are considering the blockchain, you are considering the any AI machine learning, everywhere, scalability issue is the fundamental issue rises. So we want the minimum qubits, and by using this minimum qubits, we can solve the complex problems. Okay, when we are increasing these qubits, it creates the complexity. Okay, to solve the problems, when you are increase the qubits, then it creates the complexity. So to handle the complexity is very difficult now. Due to this, we required the minimum qubit with maximum solving the complexities. Yes. So this is the first scalability issues. So error rates, then second, third is the scalability issue is the another one challenge. Then high cost and infrastructure. Obviously, high cost and infrastructure is another one challenge. So high cost and infrastructure means what? Quantum computers require the specialized environments. Yes, quantum computers requires the specialized environments. So it requires the ultra low temperatures. This is very important. Ultra low temperatures. It requires ultra low temperatures. These ultra low temperatures are close to the absolute zero and dilation registers. These two things are required to develop or to generate these high performing quantum computers. Okay. So high cost and infrastructures. That means your quantum computers require specialized environments, and this cost is very, very important. This high cost and infrastructures. This is we are saying that these are the limitations. Okay, these are the challenges. We want to build the quantum computers. Okay, as an Indian, if you are thinking or if you are doing work on these quantum computers, this is the very important concepts. We requires the quantum computers specialized environments. Okay, so we need to work on these ultra low temperatures, then registers, all these things. Okay, so high cost and infrastructure is another one challenge. So why it's expensive? Because hardware is highly specialized. Why it is expensive? Because hardware is highly specialized and it maintenance and operations costs are huge. So it requires the expert knowledge and facilities. So now if you are getting the knowledge related to these quantum computers, then they're having the very what we're saying, the very low capacities available, then technicalities available, very low technicalities available within these quantum computers. Then hardware is highly specialized. To handle these type of the hardware, special engineers or special technicians are required. That means expert knowledge and facilities, these are the available. So due to this, it will generate or it will create the high cost and infrastructures. Yes, but apart from these challenges, we need to work on these quantum computers. Why? Just I have given one example related to this cryptography. When if the quantum, just like the China or US or other countries develop the perfect quantum computers and they are generating the threats to the classical computers, just their viruses are coming into their systems, they crack or they collapse your whole system. Yes, now everyone's information is into the one server. When this cracks these servers, or when this cracks the, and it is not just uh, what we are saying, that the uh, servers informations or all others, it is affected on the common people or common man. Why? Because we are using nowadays technology, just like the UPI payments, we are using, then the different governments are uses these various systems to collect and maintain the database of the common man, common people. Then they are applying their schemes by using these common people's data sets. So when these quantum computers threats are coming and they are affecting on these type of the systems, when they are coming and these are affecting on their UPI systems or banking systems, then it's very dangerous. So after the 3 to 5 years, when China or even US, they are developing their own quantum computers and they are start to work the all the applications by using these quantum computers, and they are going into the 500 times better or 500 times faster than their classical computers. So it's a huge difference between the classical computers and our quantum computers. So we need to handle these challenges. We need to solve these complex problems, complexities, and reduce these complexities. Okay. So scalability is very, very important. We are not focusing to generate the maximum qubits. We want this limited qubits, but our work should be maximum. Okay, so scalability issue is when we are handling the scalability issues properly, then we are saying that the our quantum computers works in the proper manners. Now, future of quantum computing. Just I am showing here the timelines. Okay, timeline predictions between the 5 to 20 years. So short term 5 to 0 to 5 years improvement in current NISQ. NISQ now quantum computers are available into the NISQ state. Okay, we know that quantum computers are now available into the NISQ state. So NISQ means noisy intermediate scale quantum. Okay, noisy intermediate scale quantum devices. Now current state of the quantum computers is the NISQ states. So we are counting here zero because we are counting the current state. When we are predicted between the 5 to 20 years, first 5 years improvement in current NISQ devices, more practical use cases in the drugs discovery. This is a very important application, drugs discovery. When we are saying that in pharmaceuticals, when we are made scientists, pharmaceutical scientists made the various drugs related to the various diseases. At that time, these drugs, when we are using these drugs for the particular disease, but it affects on the other organs of the bodies of the humans. Okay, so due to this complexity is created, and these problems are handled by using these quantum computers. Quantum computers provides the multiple ways, and it can easily handles the drugs affecting to our bodies. So whatever the cancer patients or then HIV affected patients, diabetic patients, all these patients will be recovered when we are correctly, when our scientists, pharmaceutical scientists correctly uses these quantum computers when they are developing these drugs and new drugs are coming into the market. Okay, then optimization problems. Okay, so these are the two important parts in the practical use for this short term, that means 0 to 5 years. So growth in cloud based quantum access is very important. Okay, now growth in the cloud based quantum computers, when anyone can develop these quantum computers, and they provide the cloud platforms. Okay, service, cloud is the service based platforms, they providing the services. So we are like IBM and Google companies, they are almost work uh, giving their efforts to develop the quantum computers, and between the 0 to 5 years, maybe it may be they are in the full developed situation of these quantum computers. Okay, now medium term. Okay, after the 5 to 10 years, this is the medium term. In the medium terms, it's better error correction techniques. Okay, in the medium terms, because error corrections are important. Due to the various noises, errors will be generated within these qubits, and qubits are affecting the whole quantum computers. So within these medium terms, 5 to 10 years, better error correction techniques are coming into the market. Then increases in the number of stable qubits. Okay, increase in the number of stable qubits. Then early commercial applications in the finance, logistics, and material science will be coming. Okay, so this is the medium terms, 5 to 10 years. I have showing you the 5 to 10 years, but I'm not. This is a tentative tenure. Okay, if scientist works and they're showing all these things, then after the 2 to 3 years, all these are coming, and all these applications are developed within these different domains: finance, logistic, material science, by using these error correction techniques. Okay, we are roughly showing you the 0 to 5 years, then 5 to 10 years. These are the medium terms. Okay, so in the 0 to 5, we are concentrated here. In 0 to 5, we are concentrated on the NISQ phase, NISQ state. Now, whatever the, if you are writing the research papers now, every time you require the NISQ state in quantum computers, because when you are writing the paper in through these NISQ states, it will be easily accepted because it is the understate research state. We are not saying that the finally I have developed the application and we are implementing through the quantum world. Okay, you can show and compare the your results with the classical computers. Okay, compare the results with the classical computers. You can use the prototype, you can use the Qiskit programming language, some services provided by the cloud platforms from the IBM, and you can compare it. Okay, compare it to the your previous results. Okay, so medium terms error correction techniques. Okay, and you can use after that, after the error correction techniques, after the minimizations of the errors, it will be directly affecting to the each and every field. Now we are seeing that here one I have given one three examples, just like the finance, logistics, and material science, but each and every field, and mainly into the two fields. One is the drugs discovery, and second is the crypto system. These are the two mainly fields affecting these quantum computers. Okay. Then long terms. So in long terms, this is the 10 to 20 years. This is the fully fault tolerant quantum computers are coming into the world. Okay. I was showing this 10 to 20 years, but it may be after 10 years it will be coming. Yes, now the work on the quantum computers and speed of the quantum computers, you can imagine that it will be coming into the 20 after up to 10 years or 10 to 20 years. This tenure I was showing here. So in the long term, fully fault tolerant quantum computers are coming. Okay, fully fault tolerant quantum computers are coming. So ability of these quantum computers is to solve the problems impossible for classical computers. Then it breaking the current encryption systems. This is very important. Breaking the current encryption systems. Current encryption systems, that means whatever the securities provided to the your application. Just you can see here in your WhatsApp also, when we are sending the messages to the particulars, then WhatsApp messages are encrypted. Okay, just you can imagine. You can see into your WhatsApp. When you are sending the messages to the any others, then your messages will not directly going into the end users, okay, or your ends. It will be going into the encrypted formats. Okay, these facilities are provided by the WhatsApps. Due to this, we are saying that the WhatsApp is a secure. Or if these facilities not provided within their application, then we are not saying that this is the secure, because when I am sending the message to the receiver and anyone read their messages, then anyone can encrypt or anyone can theft their messages. Then it's create the problems. Okay, due to this WhatsApp, Facebooks are sending the messages in secure mode. Okay, they are now encrypted. If you are typing the whatever, hi, my name is this, whatever this, these messages will be encrypted by using the current technology or by using the current information security algorithms in the classical computers. Yes, but when after the full tolerant quantum computers are coming, and they solve the each and every problems which are not solved by the classical computers. So they are working to breaking the our current encryption systems or current security systems. So at that time, we are not saying that my message sent from me to the receiver is sending securely. Okay, so it breaks, and anyone can read your messages. At that time, we can't use the WhatsApp. Okay, on your classical computers, on your regular mobile phones, we can't use this WhatsApp. Okay, so it shifts to the post-quantum cryptography. This is nothing but your post-quantum cryptography. Okay, it shifts post-quantum cryptography. That means these quantum threads are coming here, and now we want to generate the cryptography, generate our create the environment, cryptography environment, crypto systems, which are providing the security to our system, and this is nothing but your post quantum cryptography. PQC, post quantum cryptography. This is very, very important. Okay. So now if you want to do research, you can choose this post quantum cryptography. This is a very, very sensitive topic. If you want to do the research, if you are want to write some research articles at the time, you can choose this post quantum cryptography techniques, because you can think whatever the you have knowledge, whatever the your imagination power, you can think these systems, these type of the quantum computers threats are coming and how we can defend them. Okay, so you can think on this. This is nothing but the we are shifting towards the post quantum cryptography. Yes, this will be happen. This will be happen within this 10 to 20 years, 10 years. But I'm not sure that these are the fixed 10 years. It will be happening after the 5 years or after the 10 years also. Then this is very important as per their research work, as per their works, because we are not directly working on these quantum computers due to these hardware restrictions or hardware limitations. So our scientists are thinking, can we made the hybrid computing technologies, mixing the classical with quantum computers? Yes, this is another one way to think. So hybrid computing is better way or middle way for these technologies. So hybrid computing is nothing but the mixing of the classical computers with the quantum computers. Yes. So what is mean by these hybrid quantum computers? Hybrid quantum computers will not replace the classical computers. Sorry, in hybrid computing, classical quantum computers will not replace the classical computers. Instead, they will work together. This line is very important. Quantum computers, quantum computers will not replace classical computers. Just they will work together. Okay, and this is the condition. This condition is required to us, because we cannot replace our laptop, mobile phones, or our desktop machines by these quantum computers. Okay, so scientists and researchers are thinking in this way that how we can make the hybrid computing. Okay, that means whatever the features, whatever the properties are coming from the quantum computers are mixing with these classicals. Okay, then we are developing it, all these things. Yes. And so how it works? Classical computers handles the general tasks. Which are general tasks? For example, data input, control, logics. These are the tasks handled by the classical computers. Okay, these are the general tasks. Classical computers handles the general tasks, data input, control, and logics. And quantum computers solve the specific complex problems of the optimizations, simulations, etc. Okay, then we are combinedly working on them. Yes. For example, here this example is very important. Example, in drug discovery, classical computer prepares and select the possible drugs data. Okay, in drug discovery, classical computer prepares and select the possible drug data, while these quantum computers simulates complex molecular interactions at atomic level. This is very see here. While these quantum computers simulates the complex molecular interactions at the atomic level inside the human body. So due to this, I have given an example. Na? When any patients can take the medicines for drugs for the particular disease, it can affect their other organs of the body. Okay, you know that when we are taking the painkiller drugs, then it can happen affects on their bodies. Our blood sugars will be increases. Human blood sugars, blood pressures will be increases. All these things. Okay, these are the complex molecular interactions. Now, these complex molecular interactions are handled by the atomic level inside the human body. It can be handled by these quantum computers. Nowadays, through these classical computers, we are not handling or we're not providing the platform to the drug discovery or drug scientists, discovery scientists. Okay. So these quantum computers simulates the complex molecular interactions at the atomic level. Atomic level, you can think. Atomic level means very, very small atoms, very, very small atomic level inside the body. And you can imagine when these type of the technologies are coming, then nothing is impossible nowadays. Huh? When this type of the now everyone talking on the artificial intelligence, but you can imagine these are coming, then how system or whole worlds will be changed. Okay, these are working in the atomic level inside the human body. Then whatever they are having the positive negative impact, these are the second part. Okay, positive negative impact of the every outcomes having a positive negative impacts, but you can imagine that in atomic this type of the technologies, this type of the new things are computing things are coming at that time, whatever the applications develop, and mainly in drug discovery, the applications developed through the simulates the complex molecular inside the atomic level inside the human body. So particular diseases can be identified. What type of the drugs required to handle the particular diseases, it will be created through these quantum computers. Okay. Then this helps the scientist quickly identified which drugs are most likely to work, making the process faster and more accurate and cost effectively. So whatever the coming, whatever what kind of the things you can't imagine, we can't imagine. So scientists can get easily identify which drugs are most likely to work for the particular disease, making the process is faster and more accurate and cost effectively. Okay, this is the one of the example of this hybrid quantum computing. This example is very important. You can make your search, make your research topic by using this also. Okay, so this hybrid quantum computing, it is just not replacing your classical computers as it is quantum computers. In hybrid quantum computing, we are mixing or we are working together as a mixing of the classical computers with the quantum computers. Then how it was, classical computers handles the general task just like the data input control logic. Quantum computers solves the specific complex problems just like the optimization and simulations. And this drug discovery is one of the example of this hybrid computing. Now, impact on jobs and industry. This is very important because when you are thinking of the artificial intelligence, now era of the AI, at that time also everyone talking on this impact on the jobs. Okay, AI's impact on the jobs and IT industry on every industries, because now AI changing the whole world. So AI's affects on the every industries and very important as a job perspective. So it's imaginary part, or it's after coming in the quantum computers, what exactly impact on the jobs and industries. See here, industries that will be transformed. Yes, healthcare, faster drug development will be happen. Finance, smarter risk analysis. Yes, whatever these applications, your UPI payment applications, then your banking, financial applications, all these applications having a risk. Okay, we have developed, the applications have developed their risk handling methods by using the classical computers. But when these quantum computers are coming, they need to make a smart risk analysis, or finance risk smarter risk analysis is coming. In logistic, so route optimizations. Okay. Then cyber security is very important. New encryption methods will be coming to the market. New encryption algorithms are coming. And by using these new encryption techniques, new encryption algorithms, you have to give the security to the each and every applications, whatever you are developing these applications. So cyber security is also changing. Energy sectors are also changing. Better battery and material designs are coming in through these industries, and it will be transport. So job opportunities. Obviously, just AI generates the new type of the job. Traditional jobs will be collapsed in future through this AI. Same thing will be applicable when quantum computers are coming now. New job roles will be emerge. Okay, which are these new job roles? Quantum software developers. Okay, software developers are required, but quantum software developers are required. Then quantum algorithm researchers. So you think that you have to design the algorithms through these quantum computers, then you will get the as a quantum algorithm researcher job in future. Okay. So quantum software developers is one position. Second is the quantum algorithm researchers, then quantum hardware engineers. This is very, very important. You can think that some electronics engineers, then physics background graduate or postgraduate students, and our um, computer science and engineering graduate students, when they are combined thinking on it now, these are the two highly required jobs, because in market what happens, so many less students having this type of these categories of the knowledge, so they will get the high paying jobs when they know that the all these things. Okay, so quantum hardware nowadays also specific hardware engineers, just specific high level quality in electronics engineers are not available in the market. So same thing will be applicable into the in future. So you can think that nowadays MTech in quantum computers, MTech in semiconductor technologies, MTech in AI robotics are coming. Also undergraduate branches are also coming in next 2 to 3 years. Okay, some universities from the India also they have established their course as a BTech in quantum computing or BTech in quantum computers. Already they have shown or already they have started their works. Some universities have taken their final year specializations. Electronics engineers also they have taken their final year specializations just like the quantum computing specialization. So nowadays these are coming and these are the futures technology, and US and China. I'm talking on these two countries every time because as a technology perspective, US and China, these are the two countries. These are ahead of their 50 years ahead of us. Okay, just in common language. Hmm? So you will become a data scientist with quantum skills. Yes, and we know that in every technology data is required, and as an IT engineer, as an computer science and graduate engineer, we are working on the data. Yes, and nowadays huge data is generated, huge data is generated. So if you are clicking, only clicking, data is generated. If you are placing a one dot, data is generated. And to handle this data, we require the large data scientist or large data science skills uh, students or large data science skills engineers are required. So data scientist with quantum skills, these are the future jobs. And futures means after the 5 years. Okay, for 5 to 6 years, that means when students are entering into the first year nowadays, they need to learn all these things. Okay, then and then only they will sustain into the market. So these are the different roles, quantum computers or quantum software developer roles. Then after they discussing these roles, we need to think on the which technologies and which skills we required. So see here, just start talking. Physics is very important because quantum's basic fundamental rules are based on this quantum physics or quantum mechanics. We know that, just like I have discussed, the superposition, entanglement, these type of the physics, because atoms, protons, electrons, all these are, you can study it through this physics. Okay, so you require the knowledge of the physics, quantum mechanics, and all this basic knowledge. Then mathematics, very important. If you are seeing into the machine learning, and if you are seeing into the your data scientist, you required the mathematical skills, because it's a probability, fuzzy mathematics, all these things are coming. So linear algebra and probability mathematics skills you required when you are doing the jobs with these quantum computers. Then programming, very important. Programming, Python programming language, already you know that. Qiskit is another one programming language. It is under development stage, but you can learn these programming languages if you want the jobs through these quantum computers. Okay, so these skills, commonly skills, these commonly skills are required in future: physics, mathematics, and programming. And you know that now every engineering branch is based on these three skills. Okay, you can choose any branch. These require the physics rules, these require the mathematics, these require the programming. So our students need to develop their skills through these various domains. Yes. Now, final summary for these quantum computers. So quantum computing will evolve over the next 5 to 20 years. I'm talking about next 5 to 20 years, but I don't know exactly durations. Okay. Up to next 3 years or 4 years also, it will be developed. Then hybrid system is very important. Hybrid system will dominate the near futures. Okay. To create the new industries and new jobs, then transfer the existing sectors and require the new skill in education skills and new type of the educations. Okay, so this is the final summary of his outcomes. Okay, so quantum computing is not just the technology upgrade, it is the paradigm shift. This is very important. It is the paradigm shifts. It is not just technology upgrade. We cannot say that we are upgrading our technology. We are whole changing our technology. So this is the paradigm shifts that will reshape the science, because we are studying here the physics, then businesses and security. Security is very important. If we are not learn, if we are not develop the applications through these quantum computers, then our security to the every applications, finance, banking, then your UPI applications, then your all the database from the government, central governments will be collapsed. Our military's data sets will be collapsed. All these things. So security due to this is a very important part in the with these quantum computers. So finally, quantum computing is not just technology upgrade. We are not saying that we are upgrading the, we are completed our BTech computer science and engineering, and now we are upgrading our knowledge through the quantum. It is not upgrading these technologies. It is paradigm shifts. Okay, so it will reshape everything: science, business, security. Yes. Now, so I have shown you some here images. Our India. Where is our India? What exactly doing in India? So our Ministry of the Science and Technology, central government's Ministry of the Science and Technology, they are putting their national quantum mission. So this is called India's Quantum Leap, National Quantum Mission. You can visit this website of the central government's Department of Science and Technology. So our government has established the national mission on national quantum missions. This is called as India's Quantum Leap, which is the science powered nations DST's year of achievement on the road of the to the 2047. Up to the 2047, how India will grow through these quantum computers. These are the roadmaps shown by this national quantum mission, which is called as India's Quantum Leap. This is very standard and common. You can directly search on the Google, and you can visit to this Department of Science and Technology. They will showing you the details of this national quantum missions. That means how our India will work on these quantum computers. Very important. when you are searching the various newspapers and when you are reading the news, Andhra Pradesh government is very active related to these quantum computers. And you know that this image showing that this is the Chief Minister of Andhra Chandrababu Naidu, Andhra Pradesh Chief Minister Chandrababu Naidu. They are developing the quantum IT park, Silicon Valley to Quantum Valley. Now they are started to develop or they are building the quantum IT park in Telangana and Andhra Pradesh states. So on our India's 29 states, Andhra Pradesh government is totally actively working on it, and you can search you on through the Google, you will get the news from the Andhra Pradesh. They have developed their quantum vision, Andhra Pradesh quantum vision, separate Andhra Pradesh government's quantum vision. Okay. So if you are seeing these Times of India's news, India catching up fast in quantum computing race. This news is coming in the Times of India. If you are reading this, then how these quantum computers affects on the whole every field. Okay, it is how our India's national quantum computing missions are working. It is shown by these articles, and when you are reading these articles, it can gives how did your association with India's quantum missions, then what is the quantum in simple terms, then how does one classify this, then what is the status of India's quantum computing missions, and how it compares with the global market or globally, then what are the opportunities after these quantum computers coming, then how we are providing the funds to develop these quantum computers, then what is the target to develop the qubits, then how is the private sector shaping the quantum computing in India. Okay, so all these questions will answers will be giving through this article. You can read this article. This is very important. India catching up fast in quantum computing race. Okay, so you learn this, you read these articles and learn this, because when we are thinking to become a 3 trillion, 5 trillion, or whatever the trillions economy, developing our economy, we required it. But as per the central government or as per the National Quantum Computing Mission or director of this National Quantum Computing Missions, they are posted, they are saying that it create the $2 trillion economy up to the 2035. Okay, up to the 2035, it creates the 2000 trillion, $2 trillion economy by this quantum computing. Okay, that means it affects the each and every domain, each and every field, whatever we are thinking. Okay, so this is the article you can read. It article is coming into the our Times of India. India catching up to the fast in quantum computing race. Okay, so next article is research and skilling are key to quantum success. This is very another important here. Research and skilling required. Okay, so here experts says the IT industry can transform with the quantum techs. How it is also Times of India's article, another article. Some IBM's tech, some directors from the tech companies, how they are working. Then what kind of the quantum special quantum computing presents related to economics, then various opportunities throughout the India. It will be given by these IT, yeah, these articles. So lot of interest, but India needs to speed up. Why everyone talking about this? Because China and US, they are ahead of us lot of. So due to this, research and skillings are required, or it is the key to the quantum success. Okay, these articles are also coming from the Times of India. So up to this, we are talking about the quantum computers. Thank you so much. I think near about 2 hours we have completed. Only last 5 minutes. If you have any questions, you can directly ask me. Yes, anybody having any questions? Hello, from audience. Hello.
Hello everyone. Anyone from participants ask question? Please ask.
Hello.
Yes, sir.
Sir, ma'am, anybody having any questions, you can directly ask me here. Last 5 minutes are here. You can ask the
Okay, sir.
questions.
We will wait for 2 to 3 minutes.
Yes, yes, definitely.
Okay, sir. Yes, sir. There is a question in chat. Yes, ma'am. We are giving all the sessions related material in our drive after completing our FTP. Mm, I think there is no questions.
Okay, okay.
So
So thank you so much.
I will conclude session.
Yes.
Uh, Good afternoon, everyone. On behalf of everyone present, I would like to extend my sincere gratitude to our esteemed speaker, Dr. Kale sir. Sir, your presentation give us valuable insights for the future computing and in real world application. We are truly appreciate your time, knowledge, and inspiring thoughts. I would also thanks to all participants for your enthusiastic presence and active participation, which made this session successful.
Okay,
So
thank you. Thank
thank
you
you
so
all
much.
of you and have a great day. I will share the feedback link and quiz link in a chat. Thank you so much, sir.
Thank you so much.
One second, all participants, please turn on your camera. We are taking one group photo. All participants are requested to turn on your camera. We are taking group photo. Thank you all participants. I will share the feedback and quiz link here.
Okay, thank you.